Okay, area and perimeter. Right, now the stuff that we're going to do today, I think most of you guys would have done it in primary school already, but we're just going to revise the different formulas for area and perimeter for the different shapes. And then you're just going to practice some. But what we're going to do this year, which I don't think you do in primary school, is we're going to have one shape and then another shape is like taken out of it and the section is shaded, and you must find the shaded area as opposed to just the area of a square. That makes sense. All right. So we are learning the basics so that we can apply them basically. All right. So there is a note on Classroom. I'm not going to use that note specifically for this section, but you can go take a read through. Everything is summarized there with shapes and so on. All right. But we're just going to start with area today. All right, so area, let's say of 2D, two-dimensional shapes. Later on, we're going to do three-dimensional shapes, and then those shapes don't have an area, they have a surface area. Okay, so it is slightly different. So when we're just talking about two-dimensional shapes, you can just, we're going to draw some of them. So we'll do a rectangle, which is almost like the basic one, right? That's the one you usually start with. Now with a rectangle, we know that all of these angles are actually 90-degree angles, right? Do we also know that opposite sides of a rectangle are equal? Right, I think you all know that, so we can put that in. Then another thing that you might not have discussed yet, but it should make sense, is that the opposite sides of a rectangle are not only equal, they are also actually parallel, right? If we just look at these two lines, it looks like they are in fact parallel, right? And that will always be the case with rectangles, guys. We're not going to ask you that now, but we're just discussing what a rectangle actually is. So we have that the opposite sides will be parallel. So the top and the bottom sides will be parallel, and the sides on the side, I suppose, are also parallel. Okay. Later on, possibly even in grade 9 only, you're going to actually get like lists of properties for all the different shapes. All right, the different quadrilaterals. Now, a quadrilateral is a shape with 4 sides. So a rectangle is a quadrilateral, a quad. So you're going to have to actually memorize all the properties of these different shapes. Okay, but I think we should know these properties already, right? The opposite sides are definitely equal, and I think it makes sense that they're parallel as well, right? You're not ever going to have a rectangle with 2 sides like this, and then the one side is going to go like skew, right? They're always going to run parallel to each other always. Okay, the bottom side we usually call the length. I'm just using a cursive L so that it doesn't look like a 1. And the shorter side we usually call the breadth, but it doesn't actually matter. All right, you could actually call the bottom one the breadth and the side one the length. It doesn't really matter. The area is always length times breadth. But guys, does the order in which you multiply numbers together actually matter? If I have 2 times 3, what's that answer? 2 times 3 is 6. And what about 3 times 2? Also 6. All right. So that's why I'm saying it doesn't actually matter which one is called the length and which one is called the breadth. You're going to take one side multiplied by the other one. All right. The one that's not parallel to it. Okay. So that is the area. Then if we have a square, I can just kind of try and make it look like a square. Don't stress if it doesn't really look like one. With a square, we know that all 4 of the sides are equal, right? So we can just put one line on each of those sides. With a square, we also know that we have 90-degree angles actually all the way around. All 4 of those angles will be right angles. And then, guys, it's the same thing as with a rectangle. The opposite sides, again, are going to be parallel. All right, so the top and the bottom sides are parallel, but then these two sides on the side, they will also be parallel to each other. Now for this, we're going to call the sides S for side, literally, that's what the S stands for. But you can call it any letter actually, all right? Do we know what we're going to do to get that area? Yes. Side times side, all right? It's just like with a rectangle actually, where we said the bottom side multiplied by the one next to it. We're going to do the same thing here, but because they're both equal to S, I'm going to have side times side, which is the same as side squared. Okay, so this area is, we're going to first write it as side times side, but that is actually equal to side squared. So guys, if you like side times side more, then use that. Okay, there's no problem with that. Okay, the next one is a triangle. Now I'm going to draw a few different triangles here so that we can see how we need to be able to interpret them. All right, so there's a right angle triangle like that. We've done a lot of work with right angle triangles recently. Okay, then we have another one that's actually not a right angle triangle. And then we have, let's do like this. Okay, now guys, in all of these cases, we are going to choose one of the sides as the base. The base is normally the one on the bottom, all right, the base of the triangle, but it could actually be any side, all right, we'll discuss that now. But let's put a B there, and there, and there. Okay, we'll just say that we are choosing the bottom side as the base. And now, I don't know if you remember this, but the area of a triangle, I'll write it kind of in the middle so that we know that it's the same for all three of them, is half base. So half the base, basically. So if the base is 10, then it will be half times 10, which is 5, multiplied by the perpendicular height. All right, so this symbol that I've put in front of the H, that's the symbol for perpendicular. So it's half the base multiplied by the perpendicular height. Now guys, that means that perpendicular height is literally, if we're looking at this first triangle, it would be that side of the triangle, because that is the actual height of the triangle. That is how high it goes from the base to the highest point of it. That's the perpendicular height. All right, let's add that in there actually. So perpendicular height is height from base to highest point. And just while we're talking about terminology, a vertex, that's actually the correct term for a point of a triangle, all right, is a vertex. So the perpendicular height is the height from the base of the triangle to the highest vertex, the highest point from that base. Now guys, the perpendicular height does not have to be a side of the triangle. right? The perpendicular height does not have to be a side of the triangle. It's not actually a side, guys. It's actually the measurement from the bottom line, the base, to the highest point. All right. In some cases, it will be a side of the triangle. So in the first triangle, that side is the perpendicular height. All right. You can just put an H there next to that perpendicular line because it is the height from the base to the highest point of the triangle. All right. So that would be the perpendicular height. In this case, do I have a perpendicular line? Do I have a side that is actually drawn making a 90-degree angle with the base like I have here? No, hey? So in this case, we actually have to draw in our perpendicular height. Now, guys, remember, the perpendicular height is from the base to the highest point of the triangle. So go to the highest point, which is that one. Put your ruler down, please, and draw. We're going to do a dotted line just because it's not actually a side of the triangle. Okay, I want to just show that the dotted line is actually the height. So we're going to draw a dotted line and just try and draw it so that it is perpendicular to the base, so that it would actually make a 90-degree angle with the base. So look at what I did. Okay, and just do that. Then we're just going to draw in a 90-degree angle there. That is the perpendicular height. Okay, it's from the base of the triangle to the highest point. So literally, if we were to measure that dotted line, that would be the actual height of the triangle. I hope that makes sense. All right, so the height is not necessarily a side. It's literally how high, how tall this triangle is from the bottom to the highest point. Okay, now for this one, this is a bit tricky because now I can't from the highest point draw a line that is fitting inside the triangle. Do we see? In this one we could. But guys, what is the height of this triangle going to be? From the base to the highest point, it's going to be, again, these two lines. Right? Do we see that? So it is okay to draw your perpendicular height from your highest point of the triangle, going down so that it is in line with where your base is. Okay, so again, the perpendicular height doesn't even have to fit inside the triangle because it's not a side of the triangle. It is how tall that triangle actually is. Okay, let me just see here. Have you guys done area of a circle in primary school? Did you do that? You worked with pi? You worked with that number? Not everyone, okay. Just want to check here quickly. Yeah, then I think I'll just leave the circle for after the investigation so that we can do a nice lesson on that. Let's quickly do an example here where we're finding some areas, okay? So these are the three that we're doing today. We must still do circles, but we'll get back to that. Examples. Okay, so this triangle that we're doing, it looks like the last picture that we just discussed. So we're just going to practice actually finding that area. So that is the triangle A, B, C. Okay, now guys, we are going to have to do half of the base of this triangle, right? Triangle ABC. So this extra dotted triangle that they've put on the side here, this is not actually a part of the area that we're calculating. Does that make sense? Because they're saying A, B, C. So we're just finding the area of this thin triangle here on the side, okay? So this is just like added information. Now guys, something that is quite useful, let's quickly write down the formula here. That is quite a good thing to always do. First, write the formula down and then figure out what you must sub in for the formula. So we're going to do half base times perpendicular height. Now using a highlighter or a different pen or pencil, doesn't matter. Let's actually just shade in those two sides or those two values that we're going to have to use. Now guys, if they say half base, remember we're finding the area of triangle ABC. So am I going to take the 4 as well? Is the 4 a part of the base of this triangle? No. All right, the base of this triangle is actually just this 5,6 centimeter line. That is the base of the triangle that we are finding the area of. Okay, so we're going to have to do a half times 5,6 multiplied by the perpendicular height. Now, where is the perpendicular height? It's AD. Did they give us AD? Do we know what that length is? Hey, they didn't actually tell us, right? There's no length written in there. Let's just highlight that. So that is the H that we're going to have to use. Okay, so this is our base. That is our height. Now, guys, if we don't have the height, we're going to have to do something to calculate it. Now we're going to have to use the fact that we actually have a right angle triangle as well, made up of triangle ABC and this dotted triangle here. Right? Because do I have the lengths if I'm looking at this big triangle, so triangle ACD now. All right, we're looking at the whole thing. So actually try and just ignore that line there. Right? Do you see that right angle triangle? Do we have the other two sides of that big triangle? I have the hypotenuse and I have this bottom side, right? It's 4 and 5,6 added together, so 9,6. So that means that I can actually use Pythagoras to find the perpendicular height. Okay. Then once I have that, I'm going to use it to find the area. Okay, so let's write this. Now, I just want you guys to write, it's almost like a little heading, in triangle ACD. Okay, you don't have to do that for marks. I'm just doing it because it's the example, so that if you look back and you can't figure out what are we doing, where are we using Pythag, it's in triangle ACD, the whole triangle. Right, so we're going to say h squared, that's the one that we're calculating, is equal to, guys, is h the hypotenuse of the big triangle? Is it opposite the right angle? No. Which side is the hypotenuse? Which side is opposite the right angle? Remember, we're ignoring this line. Which side is opposite the 90-degree angle? 10. So we're going to say 10 squared minus, it's always the hypotenuse squared minus the other side squared. Now the other side, you can just do like a little bracket here at the bottom. Is those two sides added together, right? Or those two lines there. 4 plus 5,6. So that's 9,6 squared. And please remember, we have to put in brackets Pythagoras. Okay, every time we use it, we must write that. I'll just grab my calculator here. Okay, so we're going to say 10 squared minus 9.6 squared. That gives us 7,84. All right, but we want h, not h squared. So what must I do to cancel out that square? I have to take the square root. All right, so h is the square root of 7,84. So h is 2,8 centimeters. Right, therefore, the area, remember, of this slanted triangle is, we said half base, and the base of the small triangle is 5,6. So we're going to say half. Now, guys, you can write it like this. That's usually how I write it. I put half base next to it, because if you put a number in brackets, it just means that you're multiplying it, right? But you can also say half times 5,6 using the times symbol if you want. And then we multiply that by the perpendicular height, which we just calculated as 2,8. All right, or you can put that 2,8 in brackets as well. All right, it's up to you, it doesn't really matter. So now we're going to say 0.5 times 5.6 times 2.8. All right, and the answer is 7,84. So that is the area. Now, guys, is area in centimeters? It's centimeters, but then because it's area, it's centimeters squared. Please remember that. Okay, you have to put the correct unit there. So you have to put centimeters squared. Yes. Yeah, I saw that as well. Yeah, I suppose it is just a coincidence. Yeah. Okay, we'll find that one, guys. So that's quite a tricky one, hey, because not only is the perpendicular height on the outside of the triangle, you also actually have to calculate it using pi fact. All right, so this is a nice typical like test question. Okay, we're going to do another one quickly. So you can just write number 2. I changed my mind. Okay, in this question, they didn't actually give a picture, but we can just draw one, all right, because we all know what a rectangle looks like. And are we understanding what they're saying when they say outer dimensions and inner dimensions? Because, guys, a picture frame is not like a solid piece of wood, all right? It's actually a border. So that's what they're asking for. They're asking for the area of that border. Okay, so they've given us the outer dimensions and then the inner dimensions as well. So let's just try and draw that. So we have, now it doesn't matter if this is accurate again. Just kind of drawing it. a bit wonky, but anyway. Right, now guys, they're asking for the area of the picture frame. So this border, like I explained already. Now, if we just take this length 18,9 and I multiply it by 13,9, that's going to give me the area of the whole rectangle, the big rectangle. Does that make sense? Right? Now, what must I then take away? Because obviously they're not asking for the area of the whole thing. They're just asking for the area of this outer bit. So I'm going to have to take away some of that area. All right, so I'm going to say that again. If I do 18,9 times 13,9, that's going to give me the area of the whole big rectangle. But now I must take something away, right? Because I don't want the whole rectangle. I just want this outer part. So which part am I going to have to minus from the big rectangle to just get the frame? What do you guys think? Yes. Good. The area of the inner rectangle, hey? Because to find this area, because this inner rectangle is not a part of the border. Do we agree with that? And to find this, we can do that. We have that length, 15, and that breadth, 10. So what am I going to do? I'm going to do the area of the big rectangle, and then I'm going to minus the area of the small rectangle, and I will be left with the area of the picture frame. Okay, so let's write that down, guys. Area of frame is equal to big area minus small area. And that's what you need to be able to do in these types of questions. You need to figure out what is the bigger shape. In this case, it's a rectangle. What must I minus from that to get the actual area that they're asking me for? In this case, it's the smaller rectangle. Okay. So the area of the big rectangle is going to be 18,9 multiplied by 13,9, right? Length times breadth. That's how we always get the area of a rectangle. Now we must minus the area of the small rectangle, which is 15 times 10. Now you're just going to use your calculator to calculate that. And you can do it all in one step. Also, you don't have to do the one area and then the other area and then minus them. It's actually better to do it all in one line like I've written here. Okay, so 18,9 times 13,9, close bracket, minus 15 times 10, close bracket. Okay, the answer, we don't know what that is. So we press SD and it gives us the decimal value. That is 112,71 centimeters. But now because it's area, we say centimeters squared. Okay, now I know we haven't done perimeter yet, but what is the perimeter of any shape? Do we actually have to know a specific formula for the perimeter? How do you find the perimeter of any shape? You actually just add all the sides together, hey? Do we know that? So perimeter is just when you add all the sides together. So let's just add a little note here. Perimeter of any shape. Guys, you don't actually have to memorize all those perimeter formulas. Okay, the only one that you will have to memorize is when we get to circles, but we'll do that later. So the perimeter of any shape any shape is the sum of all the sides. So basically you need to just make sure that you have the length of all the sides that are like on the border of the shape, and then you can figure that out and you can work that out. Right, now what if they're asking you for the perimeter of this picture frame? The perimeter of the frame. Let's quickly highlight or underline or make your shade in all the sides that would make up the perimeter of this frame. Do we agree all the way around? That would give us some of the perimeter, right? But would that give me the perimeter of the whole picture frame? Is that everything on the borders of the frame? Okay, those four sides. What about the inner sides as well? Right, because if we're doing the perimeter of the frame, that's all along the outside of it. But on the inside, you also have that in a sense. All right, so it's the same thing here. That would also make up the perimeter of this picture frame. We'll do some more work on perimeter later. I just thought I would mention it now because it's an interesting example. All right, so everything on the border, inner and outer border, that makes up the perimeter. Okay, so the perimeter of this frame, we can write that underneath here. Perimeter of frame. And guys, sure, you can set up a formula if you want, but you can also just add up all the sides, all right? And then you don't have to worry about memorizing more formulas. So we have 18,9 plus 13,9. Isn't that one also 18.9 there at the top? And this one is also 13.9, right? So we have 18.9 plus 13.9 plus 18.9 plus 13.9, right? Those four. I'll show you now how you could write it in less terms. Okay, but that's perfectly fine, just adding all the four sides on the outside together. But then we must also add these inner sides as well. All right, so that will be 15. This one is also 10 because it's a rectangle, right? So the opposite sides are equal. This top one is also 15. And this one is also 10. So guys, you can do that and that will get you the perimeter, okay? The formula that we use for rectangles, for the perimeter normally, if we just look at this quickly, do we see that we have two 18,9s, all right? So you can write it like this, two 18,9s, like that, plus we also have two 13,9s, right? So you can write it as 2 times 13,9 like that. Plus we also have two 15s. And we also have two 10s. So that's optional. Okay, I just know that some of you know the formula from primary school, 2 lengths plus 2 breadths. All right, that's where it comes from because you have 2 other lengths. So you can do 2 lengths plus 2 of the breadths that are equal to breadths. All right, so that is where that comes from. But it's also perfectly fine if you just add them together. Okay, it's up to you. So let me just quickly see what this is. So we end up with 115.6 centimeters. Now perimeter is just centimeters, okay? It doesn't change like area. So area is centimeters squared, perimeter, because it's just length around, that stays centimeters. Okay, any questions on this example, guys? I'm going to give you some similar ones now to try on your own. And then also some questions where you have like a weird shape that's made up of different shapes. All right. So I just want to show you quickly. The first one that I'm going to ask you to do is number 6 here. All right. Do we have a formula for the area of an arrow? Absolutely not. All right. So you need to figure out this arrow is made up of a triangle. Do we know how to find the area of a triangle? Yes. If we have a base and a perpendicular height, and then the area of a rectangle. So you're going to have to calculate those two areas and add them together. Now, I just want to chat about this triangle quickly. Now, the way that it's drawn, it's not actually like lying on a base. All right. So I would suggest that you choose, just going to do it like this. Just so, and I'll keep this on the board just so that you could see. I would suggest that you choose that as your base. All right. Remember, any side of a triangle can be the base. So do we agree that this whole head of the arrow is the triangle, right? So if you choose that as your base, what is this length, guys? What is the base then? They're telling us that the length is 11 centimeters, right? Do we see? So the base is 11. Now, remember the perpendicular height goes from the highest point. Now, if this is the base, then the highest point of the triangle is actually going to be that point over there. Does that make sense? So you need to be able to like visualize the triangle if it's lying on its base. Okay. So if that is the base, that will be the highest point. Now, what is the height, guys, from the base to the highest point? What is that? How tall is that triangle actually? 5 centimeters. Okay, so they've actually given you the base and they've given you the height just in a different orientation. Okay, so it's not always going to be that the base is the one on the bottom. All right, in this case, the base is there. Because could we use either one of these two as the base? Do we even have these lengths? Did they give us the lengths of these two skew sides? No. All right, so the only thing that we actually have here is that length. So that is the base. And then this length is the perpendicular height. Now, guys, for this rectangle, is the length of the rectangle going to be 17? No. This whole thing is 17. So if that is 5, what is this part? 12. All right, so the length of the rectangle is going to be 12, and the breadth is 3. Okay, so you need to be able to look at the measurements that they've given you, and from that, you need to figure out what are the measurements of the separate shapes that you need to calculate. Okay, so I'm going to give you this one to do. I just want to write down the numbers. So that's the only question from that exercise. So that's exercise 16.1. And I'm going to give you some from a different exercise. So this one is on page 186, number 6. All right, that's the arrow question. And the next question. I'm just thinking quickly. I just need to show you guys something for number 1C, yes? Times 2. Not squared, because you're not timesing them together, you're adding them, but you can do it 2 and then in brackets 13,9 plus 18,9. Yes, you could do that. Okay, guys, I just want to show you something about 1C of the second exercise, because this is something that it just comes up sometimes and then people don't know what to do. All right, so you're going to have to do 1A, which is this shape, all right, which again we can see is a funny shape that's made up of different shapes. All right, so I suggest that you actually draw this whole figure in your book, and then you do like dotted lines where you're going to separate it into different shapes. All right, so you can do like a line there, line there, line there. Then you have 4 different rectangles, for example, that you're going to add together. Okay. For C, you're not doing B, you're then doing C. Now here, do we see that it is a rectangle minus a triangle? Right? If you have to find this area of this blue figure. So it's a rectangle minus a triangle. Now they've given you that that side is 12 millimeters. And then here at the bottom, they're saying that this piece is 3 and that part there is 4. So using that knowledge, right? Because if it's a rectangle, mustn't this side be exactly the same as that one? Right? So this whole side here at the bottom is 12 millimeters, but we need to know what that part is if we want to find the area of that triangle and minus it. So what is 12 minus 3? 12 minus 3 is 9, minus 4 is then 5 millimeters, right? So the base of that triangle is going to be 5 millimeters. Now we need the perpendicular height. Now something that I'm pretty sure you wouldn't have learned this in primary school. Do we notice that this is an isosceles triangle? Right? Now when you have an isosceles triangle, the perpendicular height of that triangle will always be from obviously the top corner there. All right. Now, can I calculate that perpendicular height? I know that this is 8. So isn't this also 8? And if that is 4, what must this be? Also 4, right? Now that you're able to do. Just the extra thing, which you don't actually need for this question, but if you have an isosceles triangle, then the perpendicular height will always cut the base in half. Okay, we can write a little note on that later on. You don't need to use it in this case, but coming up in the future, you might need to use it. All right, does that make sense? If we're just looking at the picture, does it look like this perpendicular height cuts this base in half? It does look like it, hey, and that does actually happen. So if you needed to maybe work with Pythagoras to get this length, for example, to get that one there, then you could use that these are both 2.5 millimeters. Okay, we will write a note on that later on. I just wanted to show you quickly because it does come up here, but you don't actually need to use it for this one. All right, so for 1A and C, you're just finding the areas. And then the next one that you're doing is this one at the bottom, number 3. Find the area of paper on the front face of a rectangular paper envelope. All right, so this is the envelope, that's the little cutout thing, right? So you are finding the area of this, what, orange part, I suppose. Okay, so they've given you all the measurements that you need. Now guys, I'm saying that you're only doing 3A because in 3A, they're asking for the answer in centimeters squared. All right, so you are finding the area, but your answer, obviously, if you're working with these centimeters, it will be in centimeters squared. Okay. All right, I'm going to put number 6 on the board, and then you can start working, and that is your work for the rest of this lesson. Remember to please watch tomorrow's video. We're going to do circles probably and some perimeter work tomorrow, but it's only half an hour, so we might only get through marking tomorrow. Yeah. Okay, there is number 6, and then after that you're doing 16.3, 1A and C, and 3A. Okay, you can listen to music if you want, guys. There are only 7 minutes left.